Hi viewers, here we are going to discuss a topic called biosensors. The very good example of biosensor is glucose sensor, which is very important nowadays because so many diabetic patients are increasing in our country, not only in our country, throughout the world, the diabetic patients numbers will be increasing. How the glucometers are working, that only we are going to discuss. And before talking about the glucometers, we are going to know that in humans, the normal blood glucose level range between 80 to 120 mg per dl and reaching up to 250 mg per dl after meals. So that means before meal, it is the glucose level supposed to be 80 to 120, and after meal, it reaches up to 250. That is a normal. And when you go for methods, actually, for measuring glucose, there are two methods. One is optical and electrochemical analysis. And here in this glucose sensor is going to contain four important components. One is analyte. The second one is bioreceptor. The third one is transducer. The fourth one is electronics and display. See here, which is going to act as analyte. So that the glucose we are going to analyze, isn't it? So the glucose is acting as analyte here. Bioreceptor, the protein, the enzyme, okay, what we are going to keep it in the test strip, okay, is going to contain that enzyme, that protein part, which facilitate the chemical reaction, that will act as a bioreceptor. So the enzyme, which is in the strip, which is going to act as a bioreceptor, which receives the analyte. Third one is, I told you, transducer. This transducer is a part of the biosensor or the glucose sensor, which converts one form of energy into another form of energy. That means it only is going to give some electric signals. Okay. And then the last one here, electronics and display. And this is a very important component which show the value in glucose meters. So the display of the value will be given by this electronics and display component. Here, the chemistry behind this glucose sensors. Here, the glucose, the first reaction. Here, the glucose plus oxygen in the presence of an enzyme called glucose oxidase forms gluconic acid plus hydrogen peroxide. Here, the first step, the glucose is undergoing oxidation in the presence of an enzyme and forming an acid called gluconic acid and hydrogen peroxide. And then here, if you talk about the second one, the reaction, here the glucose plus that glucose oxidase forming a gluconic acid and the reducted part, the reduced part of glucooxidase. And then the third reaction is glucooxidase plus metal, which is undergoing oxidation here, okay, which forms oxidase glucose substance plus reduced form of metal plus 2H plus ions. And this reduced metal ions will undergo what? The reduction, reduced part will undergo what? The oxidation and loses 2 electrons and becomes what? Oxidized metal ions. And the given out these 2 electrons have been monitored. This liberation of electrons is very essential, and these liberated electrons will be what? Will be measured and electronically, and then the electrical signal have been recorded, and that only is given in the form of the values in the glucometers. So by this way only the biosensor, the glucose sensor works. Thank you.